There we go.
Oh, wait.
We didn't. If there were some, I would. Okay, take out your notes. I want to talk about adding fractions with variables. Actually, more specifically, everybody have your notes on? Adding fractions with polynomials. Now, some of them are pretty straightforward. In order to add fractions at all, you need what? What do you think? Yep. Common denominator. You need a common denominator. I'll abbreviate here. If the denominators are not the same, you cannot add fractions. It's impossible. You get the wrong answer. Now, the same is true when you have variables in it. For example, 3 over x plus 2 plus 2 over x plus 2. Somebody do that for me. Go. Good.
5 over x plus 2.
Exactly. 5 over x plus 2. You notice the bottom did not change at all. That's typical. If you have like 1/5 plus 2/5, you'll have 3/5. You don't have 3/10. You never add the bottom to fractions. Okay? The same thing is true even if there are letters on the bottom. If the denominators are the same, you have permission to add. So what happens if you get something like this? X over x plus 5 plus 3 over x plus 5. First of all, Joe, do you have permission to add these?
Yes.
Yes. Why?
Because it's basically the same.
True. There's specifically what's the same, that
Common
common denominator. They have the same denominator, so we have permission to add. So, let me see. Lizzie, help me out here. What do you think the new bottom is going to be? Semi-trick question. Look at the top one. I'm going to give you a hint. It's the same sort of thing. Here's another one. Like 1 over 7 plus 2 over 7 is 3 over 7.
X plus 5 on the bottom.
Exactly. That doesn't change. What's the new thing on the top? It's a little tricky. Can you add x plus 3?
Yes, but it's not
Right. Can you mush them together or no?
3x.
3x is when you're multiplying. The showdown, and I want to do a trick question.
Oh.
No, it can't. So what do you write?
You write x.
Plus,
3.
and leave it. Exactly. If there are things that don't go directly together, you leave it alone. This is your answer. X plus 3 over x plus 5. Does that make sense, Super?
Because we can't add
Right. You can try, but they don't actually combine. So you have to sit them next to each other, and that's the best you can do. It's sort of like 1 apple plus 1 orange. What's the answer? It's not 2 apples and it's not 2 oranges. It's still 1 apple plus 1 orange, and you're just stuck with it. Okay. Now there is the potential that something could be tricky. Watch this. 2x. Actually, I'm going to do this up here so I don't have to stoop. 2x over x plus 5 plus 10 over x plus 5. Somebody want to try that one? Do you want to?
You just add 2 or you do just leave it.
Mm-hmm. 2x plus 10 over, good. That seems to be the end of the problem. However, does anybody spot something that's a little unusual? Sorry.
Can the top factor?
The top, this is kind of a surprise. Wait a minute, we're adding. Why would we ever factor? Factoring makes life easier. Factoring is not supposed to be a torture. It's supposed to be useful. It's kind of like learning how to ride a bike. I don't know if anybody remembers their experience of riding a bike, but I actually do. And it was kind of, I had a dickens of a time learning how to ride the bike. When Mom took the training wheels off, I panicked like, I'm going to die. And I fell over a couple times and scraped a bunch of things. See, I'm going to die, blood. But eventually I learned, and then boom, now it's a tool I can use. So, and by the way, you don't go very fast when you have training wheels. I did eventually learn that too.
Yes,
So,
and it's a really loud tool.
Yeah,
Yes.
The GCS is 2.
yeah, and what's left behind?
X plus 5.
What good does that do?
It's over X, so it cancels. X plus 5, so it cancels.
X plus 5's cancel, what's your answer?
2 over 1.
Which is?
2.
2. Every once in a while you get lucky and it reduces. In the same sort of way, if you had 3 over 7 plus 11 over 7, can somebody reduce that? Or so first of all, add it for me. Yeah, Elijah. What's 3 over 7 plus 11 over 7?
14 over 7?
14 over 7. Does that reduce?
Yeah.
What is it?
2 over 1.
Which is better known as?
2.
2. In other words, in the same way that numbers sometimes reduce, polynomials sometimes reduce. You don't know until you factor, but they sometimes reduce. Does that make sense? So if the denominators are common, you can just add them straight away. Yeah.
Where's the number of there?
Oh, we're like here.
Yeah, right up
Here. Here.
there. Yeah, there.
Here. Oh, this is x plus 5, and I slashed it out. Just checking. Now, what if I did this? 1 over x plus 3 plus 2 over x plus 1. So, any ideas? Yeah, Susie.
Try and get a common denominator.
Common denominator. Yes, we need a common denominator. But, do you remember the only way to get a common denominator? Watch this. If I have 1/3 plus 1/4, everybody look up here and tell me if this is right or wrong. Can I just add 1 to top and bottom and get 2 over 4? No. If I tried that, is 1/3 the same as 2 over 4? No. Adding is bad for common denominators. Not that, well, actually I have been telling you that addition is kind of evil. But adding is bad for common denominators. It doesn't work. So I cannot just do plus 2 plus 2. It doesn't work. Same reason I can't do it over here. What can I do? Ricky.
You could multiply them together.
Yes, you can multiply them together. Now, interestingly enough, just for now, I'll give you permission just to leave it like this. We can always foil them together later. I just wanted to, so you can see clearly what two things are multiplying. Can somebody tell me, let me just give you a contrasting problem. Yeah, the 1 over 3 over 1 over 4. What common denominator would work with 3 and 4? Go ahead. 12. I'm going to leave it as 3 times 4, just so you see. Everybody knows it's 12, right? Now, can somebody tell me how to, I'll even put it underneath so you can see it better. Can somebody refresh my memory how to get the top numbers out of this mess? Very good, go.
So you do, for the first one you do times 4.
Yeah, 3 is times 4. So what's the new top? 4. What about the other one?
Then times 3.
Times 3, and you get
3.
3. So what's your final answer?
7.
7 over 12. Everybody right so far? But what I'm really interested in, how do we get the times 4? How do we get the times 3? Well, you can kind of eyeball it. Well, it looks like it's 4 times bigger. Oh, it looks like it's 3 times bigger. But guess where they came from? Why did this get 4 times bigger? From here. Why did this get 3 times bigger? It's not a coincidence. It's from here. In other words, let me show you up here. The 1 over 3, what they really did was multiply by 4, but you have to do the same thing to both sides, times 4. That's how they did it. As long as you do the same to top and bottom for multiplying, you should be safe. What happened over here? What are they multiplying by on top and bottom? Amen? Yeah, 3. Just got to do it on top as well. Does that make sense? Do that over here. What are they multiplying the bottom by here? It's easy. X plus 1. You just have to do it to top as well. Just go ahead and write this. See what you just did? Can somebody tell, the 1 is still there. And then, what do they multiply this by? Max. What do they multiply this by to get the common denominator?
By x plus.
Yeah, it's missing an x plus 3, but you have to do the same thing to both sides, top and bottom. So write it over here, 2 parentheses x plus 3. Oops, we got the parentheses. Does that make sense? That's how common denominators work. In order to magnify it up to the big common denominator, you have to multiply top and bottom by something. Show your work. This is incredibly important in this part. Show your work. Now, go for it. Can somebody simplify this top part? It's not very hard, but go ahead. Yeah, it's just x plus 1 over, leave the bottom just for a second. And then simplify this one for me while you're still at it. 2x plus 6 over x plus 3, x plus 1. Can somebody give me the new top? I mean, the bottom is still going to be x plus 3, x plus 1. Well, what's the new top, Johanna? I'll give you a hint, there's a 1 here. 3x? You got it. I would let you leave it like that. You have permission to leave the bottom unfoiled. If you want to foil it, feel free. 3x plus 7 over, what would that be? X squared plus 1x plus 3x plus 4x plus 3, I think. I would accept either one. These are both okay. Do you see how we got that? Some people might be asking, why would you leave the bottom unmultiplied? Isn't that kind of messy? Well, let me see if I can actually get an example. I had a beautiful example and then the computer, you've heard of Windows 10?
Yeah.
It's one of the most evil forces in all of creation.
Yeah, he was trying to hold videos and it shut down.
Yeah, it shut down and it lost my example too. I had a map thingy open, a notepad open. Done, gone. I didn't save like an idiot. But then,
I think I want to reset because I have some really useful stuff in Windows 10. So, bye.
and then it's,
Hi, aren't you happy I'm back again?
I want to kill you. That's my story of my life. So let me try this real fast.
Yeah, it's recording.
Oh yeah. Hi everybody at home. I didn't mean that literally, you know. Windows 10, Mr. Gates, Windows 10 is lovely. It's just, I don't know, it's not. I'm sorry.
You're not going to.
Bill Gates is not going to see this. Hang on a second. Hold on. Just a second. So, hang on. So, hang on a second. This will take like a minute. So, Yeah, just a second, hold on. I'm trying to reconstruct what the computer destroyed. Ooh, I think I got it, 10. Minus 10 minus b minus 2. 4b equals 2. Ooh, I got it, 10. B equals 2. Never mind. Part of the reason, I'll just give you the end result. The question I was asking, let me look up here, please. Back again. Part of the reason what I was getting at is, why would I ever leave it unfoiled like that? Well, let's just say you have, blah, blah, blah over x plus 1 plus another blah, blah, blah over x plus 3. And I get something over x plus 1, x plus 3. What if I happen to get this? Is there any advantage to leaving these things in separate parentheses on the bottom? Yeah.
Because then you could, do the greatest common factor at top, which
Like
is
what?
2x plus 1.
Does anybody see the benefit of leaving the x plus 1, x plus 3 separate for a few seconds? Why? What's about to happen? These will cancel. And you get 2 over x plus 3, which is much, much nicer. So, over here, if I had multiplied this out, if I had written like this, watch this. 2x plus 2 over x squared plus 4x plus 3. Does anybody see off the top of their head that anything cancels? I don't either. I can't see a thing. I can't cancel the x's, I can't cancel the x squareds. I figured I'm done. I wouldn't be. That's why I would say hold off for 30 seconds to factor don't foil the bottom yet. Leave them as separate parentheses for like 30 seconds. And then take a good solid look. Maybe something factors. Now, that only happens like 10% of the time, but it does happen 10% of the time. So, if it reduces, you will be grateful. Also, if it reduces, I want you to reduce it. And I will take off points if you don't. Lizzie, question?
Wouldn't be done boiling?
I'm sorry?
Wouldn't be done boiling?
Oh, in other words, when would I multiply these two bottom things together? After I'm done checking to see if anything factors or not, cancels. If nothing cancels, then go ahead and put them together if you want. Although I give you permission to just leave them. FOIL together means multiply x plus 3 times x plus 1. That means just multiply those together. You'll get x squared plus 4x plus 3. Okay? John? Yeah, sorry about it. Everybody clear? Let me just highlight something. Everybody look over here. Ladies? Everybody. I want my eyes pointed at me and brains focused on me. Here, I definitely want you to simplify the top. You must distribute and combine the top. The top must be combined. Must. The bottom, hold off. Because the bottom may have pieces to cancel. The top, if I never added these, I never would have known. Because if I had like, I don't know, x plus 1 and x plus 1, actually that would have been dumb because it would have canceled. Well, how about this? X and then x plus 2, that works. I mean, if I had this, no, that wouldn't work either because now I'm denominator. Whatever. But if you had like, how about this? If I had x over x plus 1, x plus 3, plus x plus 2 over x plus 1, x plus 3. Think that makes sense? Take a look here. Just a second, put your hands on just a second. Would I just leave the tops as is? No. I've got to combine these because I would never know if anything actually cancels. The bottom, leave in parentheses. The top, do not. See the difference? The top must be simplified at all costs. The bottom, you can hold off for a minute. Like,
For the bottom right problem that you have, can it be factored again? Because there's two x's being multiplied together and 3x being multiplied together.
We're talking about here?
Yeah.
Well, this came from here. These are identical.
Yeah, I know, but like.
So can this factor? Yeah, it factors into x plus 3, x plus 1.
Well, I meant like, can the top x.
Can the top factor again?
No.
What?
Can the top x go into the bottom x? One of the bottom x?
Short answer is no. It has to be a parentheses and a parentheses that'll cancel. It can't be just a piece. So you can't cancel this x separately because there's a
Can't
plus,
there be a parenthesis?
plus sign in the way.
Can't there be a parentheses around the x?
Yeah, but there's still a plus because it's part of something bigger. We're looking at binomial, 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 binomial. So in other words, if you want a whole parentheses to cancel, it's got to be the whole thing or nothing. If x is added to something, you're forbidden to cancel it.
Okay.
Ever. Forever and ever and ever. Amen.
Amen.
Yeah, thanks. Now, let's take a look at the homework. We're looking at page, open your book please. I believe it's page 439. Oh. Wrong page. Page 439, roughly, this is 11C. There's some review problems. Number 1C is interesting. I'll let you do that on your own.
Yeah,
And it says, find the sums and differences. Look at problem number 4. Every single one of those has a common denominator. You're welcome.
Oh my god. We can do all day. Wait, really?
Yes.
Well, this is
For so long.
Whoa, slow down. By the way, 4A. 4 over 7 plus 3 over 7 is 7 over 7, better known as 1. Congratulations, you're done with that problem. These go fast. On page 439, everybody on the right page, first of all? Problem number 4, with the billions and billions of sub-problems.
16, 17 is done. No wonder they work.
Everybody listening?
There's 16,
Okay.
18.
KLM, NOP, QR. Yeah, don't forget there are Q and R in the next column. So yeah, there are 18 of these things.
Yeah.
But be careful. Although they're common denominators, some of them are subtraction. Look at number 4P. I want to do that with you together. Number 4P is in Patrick. I may need somebody to read it up for me. Hang on a second. Let me get some space. Hang on a second. I gotta get some space. Okay, go ahead.
X over x plus 2,
X over, I'm sorry.
x plus 2,
Okay.
and then minus x plus 3 over x plus 2.
Over X plus 2. Good enough. This is 4P. So this is part of your homework, so if you write this down, you get a freebie. You notice subtraction? There's a potential danger here. First of all, I hate subtraction for many reasons. This is one of them. I like adding the opposite. How many opposites? Good.
2.
2. Top or bottom?
Both.
That would be 4.
Oh.
At on the top. First of all, let me show you this. Negative 1/2. Question, is this equal to negative 1 over negative 2? No. Somebody prove it. Olivia, why not?
Because if they're both negative, it would be equal to the entire thing being positive.
Correct. The two negatives would cancel and make positive, and that spoils your answer. So you can do negative 1/2 is equal to negative 1 over 2. You can also do 1 over negative 2. However, this part is not the greatest idea. Why? Because if I did this plus opposite opposite, that's legal, but guess what it just spoiled? I want to add fractions, the common denominator. This is not a common denominator anymore. I don't have negatives over here. 2 and negative 2 are not common denominators. So what I want to do is opposite opposite. And I can't do top and bottom at the same time for 2 reasons. Number 1, it spoils the common denominator, and number 2, it's just plain wrong. This is much better. Does everybody say the answer is going to be over x plus 2?
Yeah.
Like 1/7 plus 2/7 is 3/7. Somebody give me the new top. Good.
2x plus, no,
I'll give you a hand. Here's 1, here's -1.
we can love both x's.
Ah, interesting. 1x plus -1x plus -3, these cancel. What's the only thing left? -3 over.
X plus 2.
There's your answer. Make sense? So, what just happened here? When you subtract, add the opposites, there may be 1 to 1, on the numerator, on the top. Never mess with the bottom. Never make the bottom negative if you can avoid it. Everybody kind of understand that so far? I'm sorry, I didn't hear you.
So you change it to addition and then what part?
Add, and then you make the entire top negative. If there are 5 parts, you switch them all.
And why would you do making it negative?
Why would I what?
Why would you make it negative?
Because whenever you add, whenever you subtract, you're really adding the opposite.
Yeah.
So if it's subtracting a positive, you're adding a negative.
Yeah.
These were both positive in the first place, but I'm subtracting them. So I had to add the opposite. Okay. Let me see. Some of those other ones are. Let's take a look at look at number 5. Notice you don't have to do. Let's try that again in English. You don't have to do all 5. You have to do A, C, E, G, I, K. Okay, so skip around. Don't do 5B, don't do 5D, etc. Just look at your homework guide sheet carefully. And then the only ones you have to do for 6 are A and C. I would strongly suggest you use crisscross across for number 6. You don't have to, but it's nice. Max, question. Number 1. Number 1 is factor into primes. That means keep splitting and splitting and splitting until you can't split anymore. Like this. 18 splits into 9 times 2, which splits into 3 times 3 times 2. That's what they're looking for. Only do that with the number 5022. It's big, I'll be the first to admit that. But, go for it. And it'll test your divisibility knowledge. Yeah. Which one? 4 or 5? 4. 4F, okay. Can you switch them around?
Can we reduce it?
It kind of depends. Look at number 4F. I'll give you a hint on that. Everybody see it? It was 8 plus x over 5 plus 2 plus x over 5. Combine the tops for me, somebody. What do you got, Max?
2x plus 10.
Yeah, 10 plus 2x, or 2x plus 10 if you like. 2x plus 10 over what? 5. So number 4F, all right, I'll even give it to you. It's, I'm sorry, what was it again? X plus what? X plus 2 over 5? And then plus x plus 8 over 5?
Yeah.
And you said it was 2, I flipped these around, it was 2 plus x. So you got 2x plus 10 over 5, which is correct. Is there anything you can do on the top? There's a GCF of what? 2. What's left behind? X plus 5 over 5. Question, does anything reduce? Can I reduce the 5 and the 5? No, the top 5 is trapped. It has a plus sign next to it. Can I reduce the 2 and the 5? No, they don't go together. Can I reduce this 5 and this 10? No, plus sign. Guess what? You're done. This is fine. This is fine. Either way, it's fine. That make sense? All right, number 5, get a common talk today. Get a common denominator first. Would anybody like to pick one to work for number 5? I will do one of them of your choice. Make you good. We're on page 439. Either 5A, C, E, G, I, or K. Pick whichever one you think would be interesting. Number 5 what?
We don't have to do that.
We do not have to do 5F. Suggestions?
J.
5J? Okay.
Wait, we don't have to do J.
We do not have to do J. Correct.
Just do K.
5K?
Yeah.
I can do that. So x over x plus 1 plus x over x minus 1. Let's try it. Was it plus x over x plus 1?
X over x plus one plus x over x plus
Like that? Okay. Let's try it. In order to add fractions, even when they're tempting, some people might look at this and say, hey, do the plus 1 and minus 1 cancel? No, they do not. Because I can't add when they're not common denominators. I would strongly suggest you put parentheses around everything. Because it's kind of like putting on battle armor right before a war. Like super duper, like bulletproof battle armor. Wrap, 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 wrap. Okay, now, how do you get a common denominator? Go, Susie.
one. More plus
Yeah, what is this missing?
x minus one.
X minus 1. It means you have to do the same thing to both sides. Did you see what I just did? If you're not looking up on the board, you probably missed it. Please look at the board and read it. Do you see? This was missing an x minus 1. So I put it on top and bottom. What's this missing? Mary Kay. An x plus 1, but you have to do that on top and bottom. Does that make sense? Elijah?
Can't you just do crisscross across?
Yes, but I want you to know this technique because crisscross across only works with 2 fractions.
Okay.
Eventually they'll give you 3, and then crisscross across doesn't work. This technique always works. So tell me, what's the new common denominator? Oops, sorry, supposed to be plus. Joe?
X plus 1, x minus 1.
Yeah, x plus 1, x minus 1. Just leave it like that for a second. And then we give me the new top here. I do ask you simplify it though. The top always simplify. Go, Susie.
Squared minus one.
Yeah, x squared minus 1x. I'm going to do plus negative 1x. And then do the other one for me, Sarah.
X squared plus 1.
Yeah, x squared plus 1x. So this whole thing, when you get done adding, does everybody see we now have a common denominator? Leave the common denominator, x plus 1, x minus 1. What's the new denominator? Joanna, take over. Add that top for me. I'll give you a hint. There's a 1 in front and a 1 in front. 2x squared? Yeah, the 1x and the negative 1x cancel. Now then, does anything cancel? Yeah.
The x plus 1, x minus.
No, those are multiplied. Does anything on the top cancel anything on the bottom? Like, do you see a parentheses x plus 1 on top? Anywhere? Dot. Dot. Is there an x plus 1 up on top? Up here? No. Is there an x minus 1 up there? Say again? No. You'd see it visibly. It'd be parentheses x plus 1 or parentheses x minus 1. Could I factor this and get one of these? No. If this are 2x squared plus 2x, I'd say, oh, maybe there's a GCF. But there's just one term. I can't do anything with it. Guess what? You're done. Okay. Anyway, is everybody feeling okay on this? The rest of the hour is yours to pound away at it. You got about 15 minutes. Go to it. Call me over if we get stuck, or come on over, whichever you prefer. And go to it. And I think I can hit the